بسم الله الرحمن الرحيم وبه نستعين. الفيديو ده بيتكلم على جزء from the syllabus of secondary physics unit 1 chapter 2 which is sound. الفيديو ده بيتكلم على vibrating strings. جزء من unit 1 chapter 2 second physics. When a string is fastened at both ends, عندي هنا string fastened يعني connected from both ends and blocked at some points, it will vibrate transversely by different modes. It will vibrate transversely by different modes. Waves in such strings is called standing or stationary waves. يبقى this is called standing or stationary wave, which result from incident wave ادي incident wave ادي reflected wave. When they superpose each other, it will produce standing or stationary wave. In standing or stationary wave, there will be antinodes, points of maximum displacement, and nodes, points of zero displacement. This shape is called a segment, and the wavelength in a standing wave is the distance between two successive nodes. ادي node وادي node multiplied by 2. The wavelength in a standing wave, as we said now, nodes, places of no vibration. Nodes ادي node وادي node وادي node, places of no vibrations. Antinodes, places of maximum vibrations. Wavelength of standing wave lambda, wavelength of standing wave lambda equal distance between two successive nodes multiplied by 2. ادي node وادي node, the distance between two successive nodes multiplied by 2 gives the wavelength in standing or stationary wave. يبقى ده عندي ايه؟ عندي string fixed from both ends and blocked at certain points. It will vibrate transversely, producing a standing or stationary wave. The standing or stationary wave consists of antinodes, places of maximum displacement, and node, places of zero displacement. This shape is called segment. يبقى we have here 3 segments. The wavelength in standing wave equal wavelength of standing wave lambda equal distance between two successive nodes multiplied by 2. Modes of vibrations in strings. If the string produce one segment only, يبقى number of segments اللي هي ال n small n دي number of segments equal 1. يبقى the string here vibrate produce one segment. It will give a tone which is called fundamental tone. If the string vibrate produce 2 segments, يبقى number of segments n equal 2, it will produce a tone which is called first harmonic. If the string vibrate produce 3 segments. يبقى n اللي هي number of segments equal 3. It produce a tone which is called second harmonic. If the string vibrate produces 4 segments. يبقى ال n قلنا ايه؟ number of segments equal 4. It produce a tone which is called third harmonic. يبقى the name of the tone is determined by the number of segments. If we have 1 segment, we have fundamental tone. If we have 2 segments, we will have first harmonic tone. If we have 3 segments, we will have second harmonic tone. If we have 4 segments, we will have third harmonic tone. In general, length of a string equal n number of segments multiplied by lambda divided by 2. يبقى ال L in case of second harmonic هيبقى L equal 3 lambda divided by 2. هيبقى ال L in case of first harmonic هيبقى L equal 2 lambda divided by 2 and so on. Lambda equal 2L divided by N. L length of the string, N number of segments. يعني in case of third harmonic هيبقى lambda equal 2L divided by 4. In case of fundamental tone هيبقى lambda equal 2L. In case of fundamental tone هيبقى lambda equal 2L لأن in case of fundamental tone N equal 1. With respect to frequency of the wave in the string equal NV divided by 2L. V velocity of the wave in the string. In case of first harmonic هيبقى الفريكونسي equal 2V divided by 2L. In case of second harmonic هيبقى الفريكونسي equal 3V divided by 2L and so on. Ratio between frequencies F node, which is the fundamental frequency, to the frequency of the first harmonic, to the frequency of the second harmonic, to the frequency of the third harmonic. Its ratio is 1, 2, 3, 4. In a string, to calculate frequency in a string, F equal N number of segments divided by 2L multiplied by root T divided by M. What is T? T is the tension of the string in Newton. And this M, this small m, is the mass per unit length in kilogram per meter. يبقى to calculate frequency of the wave, of standing wave in a string, equal N number of segments divided by 2L length of string multiplied by root T tension of a string in Newton, M mass of unit length in kilogram per meter. Factors affecting frequency of a string. Number 1, number of segments. N, N اللي هي number of segments equal mode plus 1. المود في الفundamental tone number of segments equal 1. المود في الفيرست هارمونيك يبقى 1 plus 1 يبقى number of segments 2. ال N في الثيرد هارمونيك يبقى هنا third، يبقى third هي 3 plus 1 هيبقى 4، يبقى number of segments in third harmonic equal 4. يبقى first factor affecting frequency of a string is the number of segments N. Second factor, length of a string L. The length of a string L is directly proportional to frequency. Square root of tension root T. Tension, as we said now, is measured in Newton. Square root of mass per unit length. As we said now, mass per unit length is the in kilogram per meter and equal rho density of the material of a string by 3.14 r square radius of a string square. A root of mass per unit length is inversely proportional to frequency of the string. When a string vibrates, it produces sound of same frequency. When string vibrates, it produces sound of same frequency but of different wavelength. The velocity of sound in air equal lambda frequency, as we know before, while velocity of the wave in the string is calculated from root tension divided by root mass per unit length, tension in Newton and the mass per unit length in kilogram per meter.